Hello, let's continue our Sudoku adventure with Unique Cages by Jaze. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these cells surrounded by dotted lines. Those are called cages. Digits in a cage sum to the value on the top left. So this could be, for example, 1, 5. 1 plus 5 is 6. That would work. Additionally, killer cages of the same value have different composition of digits. So we can ignore this 3-cell one because it's the only 3-cell cage, meaning nothing's going to have the exact same composition of digits as a 3-cell cage if it's only 2 cells, right? But what that means is, for example, these 2 7s have to have different composition of digits. So if this was 1 plus 6, this could not also be 1 plus 6. This would violate the rule. We could do 2 plus 5, for example. That would be fine. All right, and that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, well, a 7 cage is 1, 2, 4, so we can start with that. Okay, yeah, and we have two 5 cages. So these are the 2 ways to add to 5. We could do 1, 4 or 2, 3. So these are just from 1, 2, 3, 4, but they're different ways of adding to 5. I suppose that means this cell sees both ways to add to 5. So it can't be 1, 2, 3, or 4, because those are all going to be used in these 2 cages. So this is only 5, 6, leaving 1, 2 for here. The 6s do something similar. These are either 1 plus 5 or 2 plus 4. That's the only 2 ways to add to 6. Can't do 3 plus 3 because it repeats the 3. Excuse me. The cough drop ran out. My apologies. One moment. All right, so I was saying that there's only 2 ways to add to 6. 1, 5 or 2, 4. Can't do 3 plus 3. Can't do 6 plus 0. And that sees this cell here. So this cell here is only 3, 6, the last 2 digits remaining. Now, can we do anything with that? I'm not sure. Okay, so the last thing we have is we do have 3 7 cages. So there are exactly 3 ways to add to 7. 1, 6, 2, 5, 3, 4. Okay. So something interesting about that is it does cover every digit. That's the thing about 7 cages and 6x6s is you can put any digit in them. But this is going to split up the digits into 3 groups. 3 groups that add to 7. So let's actually color that. Let's make this green, this can be purple, and this can be blue. Why not? So we know that these are, whatever green is, it's 2 digits. Purple is 2 digits, blue is 2 digits, and they're all different digits from each other. So if we look at this box here, we can see that these 2 can't be purple. And these definitely aren't purple, so the purple goes here, which does leave 2 cells for blue. This column needs 2 greens. Okay, so I'm already seeing that we already know green is not 3 or 4. And so that means this can't be a 4, and that does put a 4 over here. So 1, 2, so this is the green 1, 2. There are not 2 green 1, 2s. Otherwise 1 plus 2 would be 7, and it's not. So this is the 5, 6. Basically, we can think of this as a 7 cage. We also think of this as a 7 cage and this as a 7 cage. All right, so if this is a 7 cage, then we could do 1 plus 6, 2 plus 5, or 3, 4. I'm not sure how helpful that was. Actually, it means blue has a 1, 2 in it. Oh no, purple could also have a 1, 2 in it. Never mind. No, that was wrong. Okay, well, let's look at this box then. Maybe there's something helpful here. Because we can think about this as a 7 cage. So if that adds to 7 and these add to 6, we can add those up. 7 plus 6 is 13. Now we know the entire box adds to 21. So to get from 13 to 21, we need 8. So these 2 cells need to add to 8. So basically 6 plus 7 plus 8 is 21. So if these add to 8, we can't use the 1 or the 2, so we have to be 3, 5. Nice. Okay, so that makes this 6 and 1. So we know that green is 6, 1. Okay. And then this can't be 1, 5, so this is 2, 4. And if this 6 is 2, 4, then this 6 is 1, 5. These aren't 1s, they're a 2, 4 pair. We get our 3 here. Now in this column, we need a 6, and then this is 2 or 4. So let's just do this. 2 would go with 3, 4 would go with 1. Oh, and 4 cannot go with 1, so this is 3 and 2. So that means this, so we need a deep in the corner, but it also means this can't be 2, 3 by our rule of distinct digits. So this is 4 and 1. Now that we have a 4 in purple, we know it's 4 plus 3. So this is 3, 4, and this is 2, 5. Resolve that. This is also 2, 5, which is resolved. This 5 and 1 is resolved. 4 and 2 is resolved. 5 and 3, 2 and 4. All right, and I'm going to get rid of our colors at this point. We don't need them. This is a 5 for the column. Here we need a 2 and a 6. Where else should I look? How about here? This is a 6. Remaining 2 digits here are 1 and 5. They go like that. All right. This is 3 or 4. And then this is our 6. This is 4. This is 3. This is 4. This is 3. And then up here, we do need the 1 and the 4, and we're done. All right, neat puzzle, Jaze. I really enjoyed that. Unfortunately, this is the last one in the queue I have for Jaze, and Jaze hasn't been around for a little bit. Not sure what's going on with him, but I'm sure he's just taking a break or whatever, really busy with other things. But yeah, so this is our last Jaze puzzle until he decides to return and set more puzzles for us. So thank you, Jaze, for all the puzzles so far, and we hope everything's going well. Well wishes to you. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.